Okay, so suppose you are at a party with n people, labeled from 0 to n minus 1, and among them there may exist one celebrity. May exist, so we need to make sure that it's not always happening. So, what this usually means is you should have a test case of no celebrities because that will be tested somewhere. The definition of a celebrity is all the other n minus 1 people know him, her, but he, she does not know any of them. Oh, nice. Nice, nice, nice. Now you want to find out who the celebrity is or verify that there is not one. The only thing you are allowed to do is ask questions like, "Hi A, do you know B?" That's a that's a good question to ask. That is very good. Uh, do you know B? To get information of whether A knows B, you need to find out the celebrity or verify that there is none by asking as few questions as possible. This is great question. This is like good puzzle actually. So let's just see this. If we ask if A, like if A knows B, right? Two responses can come up: yes and no, right? Now if yes, say we ask next question to B, B knows C. So now um, if yes comes up, we can actually ask C if C knows B. If yes comes up, we can ask D knows B. Yeah, yes comes up, so on and so forth, right? But this will still take often. A simpler way would have been, say there are A, B, C, D, E, F, G, right? So if there are these and say G was a celeb or say B was a celebrity, right? Then we need to know that A also knows B. You are given a helper function. Is there a transitive rule in place? Like if I know that A knows C and C knows B, can we say that A knows B? Like if that kind of rule exists, then we can. Then it's a good question, right? Otherwise, otherwise it gets down to just checking, right? For B, if A knows B, C knows B, D knows B, we'll have to check for every case. Yeah, if no comes, then that will still be somewhat interesting. But let's just read the rest of the question. You are given a helper function bool knows AB, which tells you whether A knows B. Implement a function and find celebrity N. There will be exactly one celebrity if he she is in the party. Return the celebrity's label if there is a celebrity in the party. Okay, if there's no celebrity, return one. So if input graph was something like this, right? How do you represent the graph here? Essentially, we are not given the graph anyway, which is weirder, right? Anyway, we have to use the knows part. So here 0 knows 1 and yes. So we can ask 2 knows 1, yes. Then we are sorted, right? If we got n minus 1 responses across one person. Let's just think what happens if A knows B and the answer comes out to be no. Then first thing we should ask is, does B knows A? If yes comes up, then C knows A. Yes comes up. D knows A. Say now no comes up. What should we do? D does not know A. So A is not the celebrity. B is also not the celebrity because as soon as uh, we get to know the first of all, these celebrities are named not A B C D. They're named 0 1 2 3 4 5. But anyway, this I hope this makes it somewhat simpler for some people at least. If D knows A comes to be no. Right. Then what do we do? Man, I need some water. Uh, Comes out to be no. Then one thing we can probably do here is A is not the celebrity anymore. B is not the celebrity anymore. Oh, wait. There was a catch here, right? The definition of celebrity is all other know him or her, but she does not know any of them. Ooh, okay. So if A knows B and answer comes out to be no, right? Right. And B knows A. If he asks B knows A, does B know A? Like if if A knows B and the answer is no, then there's a chance that A is celebrity. So we can check if B knows A. If this is, if yes, then possible celeb. If no, A does not know B, B does not know A. Thing is that whoever becomes our candidate for celeb needs to not know anyone else, and everyone else needs to know him. If you do a simple pass, an O of n pass, that 0 knows 1, 1 knows 2, 2 knows 3, 3 knows 4. Say there are like 5 people only. Right. And in this case, let's say, consider the case where 3 is a celeb and 1 is a celeb and no celeb, right? I just want to see if one pass can do it. If we have to do n square, then anyway it's simple enough, right? Because then it gets down to just finding every pair and just checking for them, right? If for every pair you'll know if they know each other or not. That's an O of 1 operation anyway. Okay. So if 0 knows, so if 3 is a celeb, right? Um, then 2 knows 3 will be yes. That is something we are certain of. 3 knows 4 will be no, right? Now what I want to check is, can we be certain from this that whatever these answers may be, that the celeb is 3? Like if say yes, this is yes, and this is no. If this is no, that means 0 could be celeb. If 1 knows 2, yes, then 1 can't be celeb. First of all, if anyone knows anyone else, it can't be a celeb. 2 can be a possible celeb. But 2 knows 3 comes up. So 2 can't be a celeb. So now we're down. 3 is a possible celeb. 3 knows 4 no. For every person, if we just check for how many ones should we check for, man? It comes down to as soon as we find a single person that this guy knows, then this guy is not a celebrity. And then you can move on to the next person. And then again keep checking. Uh, do we need to check the previous guy now? Because we checked A knows B, we never checked B knows A. And A is not a celeb, we figured that out. So if A is not a celeb, there's no point checking anything about A again. Right? We need to find a celeb, or if none exist. So when you checked A knows B, oh no, for A we are considering a possible celeb. In that case, you need to check B knows A, C knows A. I don't know if we should search for a celeb or we should search for a non-celeb. A non-celeb is like you keep iterating. As soon as you find a person, okay, this is still seeming to be n square, but let's anyway go ahead with this. For I in range n, I is your person, so let's just call him person, right? For other person in range n, if person is equal to other person continue. Else also if knows person other person, if person already knows somebody, then person can't be the correct guy. Break and then the next person's gonna come up. For the next person again we're gonna check in all. So how do we know? So n would be 1, return, or if n would be 1 then we return 0, which is the only guy who's a celeb essentially. N equal to 0, return -1. This is clearly n square, not gonna work. What? Wrong answer? Uh, okay. So 1 knows 0, 0 knows 1. Then we'll check for 1 as a person. And we'll check 0 here. They are not equal. But 1 knows 0, yes. So not a celeb gets true. This breaks. Person is not a celeb. So here there are no friends essentially. Maybe we can do it other way. Let's say celeb to true. Whether person knows this person. If not, the person knows this person. Select the false. No. What? How am I screwing up this question? 1 1 1 1. That means 0 is connected to 0 knows 1, 1 knows 0. So when we check for 0, celeb is set to true. 1 knows them. But 0 doesn't, 0 should not. Okay. So only when we ask that, hey, this guy knows somebody other than yourself. All we get is a candidate. person in range n. So many mistakes I've made. Don't know how I'm making these many mistakes. In any case, I should reattempt this problem sometime. So 0, of course, 0 knows 1, 1 knows 2, 2 knows 1, 0 knows 1, 1 knows 2, 2 knows 1, 0 knows 1, 1 knows 2, 2 knows 1. Since 2 knows somebody, 2 is not a setup. 1 knows somebody, 2, 1 is not a setup. 0 knows somebody, 0 is not a setup. If person knows any other person, not celeb gets true, and we can I don't feel so good about this. Even though we solved it, we had so many different issues crop up here. Plus, this does not seem like the best way to solve it, for sure. Because for every person, I'm just checking if that guy knows somebody else, then he's not a celeb and we can break. Uh, and then I'm adding a bunch of candidates. As soon as I get more than one candidate, I'm returning again. As for the problem statement for a given person I, we can check whether or not I is a celebrity by using nodes. Uh, you can do far better. See, I told there must be a better way. What we actually have in the problem is a graph. Fair. Where directed edges going from person A to B means that we have confirmed that A knows B. For example, here is the possible graph. Assume that we have made all possible calls to nose API to find these edges. Is there a celebrity here? Hey, then it's very easy, right? You have to kind of just go through the nodes to see which node has the most edges coming to it, right? Or which nodes in the adjacency matrix, if you are able to construct that, then you just need to check which row has all ones, right? uh, in this case 4 is the celebrity. In this case 0 1 5 is no celebrity here. 0 is a celebrity. The graph resolution has a person who has exactly n minus 1 going in and 0 edges going out. 0 edges going out is a very important thing. Yeah, that's happening. On the first example, person 4 is a celebrity. Right, 3 is not a celebrity because okay. The second example, there is no celebrity. Third example, there is also no celebrity because 0 is having an edge going out. At the start, we only know the nodes of the graph. The edges are all hidden. We can uncover edges by making calls to nodes API. In the first approach, we uncovered all edges this way. So the question we need to ask now, was it actually necessary to uncover all of them? A good way to answer this question in an interview is to walk through an example on whiteboard where you decide which edges you want to ask for and then draw them as you go. When you do your own example, you'll of course need to know what the full graph behind your example is. Of course, right? Or at least the important aspect set. But you also need to focus on what information you've uncovered by using nose API. Here's an animation to distinguish between not A knows B, and we haven't yet asked if A knows B. We use a green solid arrow to show A knows B and a red dotted arrow to show not A knows B, and no arrow if we have not asked. So does 5 know 2? Yes. Does 7 know 1? No. Does 6 know 5? No. Does 6 know 1? Yes. Does 4 know 1? Yes. Does 3 know 7? No. Does 4 know 6? No. 0 know 1? Yes. If 6 knows somebody, there's no point asking, oh, okay. Because you already know both 4 and 6 know at least one other person. This means that neither of them could be a celebrity. Therefore, we have already ruled them out. There was no need to investigate them further. So, what we can conclude from the result of A knows B check? The result was true. Could A be celebrity? What about A? And what if A knows B return false. Who wouldn't be a celebrity now? Oh, now B can't be a celebrity because A does not know the person. Nice. With each call to nodes, we conclusively determine that exactly one of the people is not the celebrity. N minus people in O of n time. We start getting 0 might be the celebrity candidate. Then we check if 0 knows 1. Within a loop. If true, then we know 0 isn't the celebrity. But 1 might be. Update the celebrity candidate variable to 1 to reflect this. Otherwise, we know 1 is not a celebrity. Great, yeah. This is great solution. Okay, there's another approach here. Let's just check this also. So what they're saying is even though it's O of n, nose could be a slow call. Okay. What are they suggesting? Essentially, I didn't get it. What are they suggesting? This is a good explanation. What they're saying is we're just retrieving, we are just caching all the calls beforehand. Great problem, yeah. I made silly and it's not optimal also. Cool. Thank you guys. I hope this was, I don't know, this would not probably have been as helpful, but never mind. Sometimes things are like that. Bye bye.